Is it okay?
Yes.
Okay. Hello everyone. I'm Chalavadi Vishnu. I recently joined IIT Tirupati, I think 4 months ago, and I'm currently about to give a talk on a deep learning perspective to signal processing. My main area is computer science and technology, but I wanted to give a unified perspective on how it can affect other departments also, especially EC department, because we will be focusing on signal processing, and I want to give I want to thank for the introduction already given, because I put very rudimentary information, but I think the biodata was well introduced. Thank you. So yeah, I want to talk about the topics here basically. So along with that, I work in adversarial learning, federated learning, and especially aerial image analysis. So for areas like this where we are working on farmlands or industrial areas, so we need analysis of what kinds of lands there are even before the construction begins. So for civil departments, what kind of lands they can actually work on, what kind of lands, how to analyze them. So aerial imagery analysis takes care of it, and trajectory prediction. So this is basically for mechanical department or mechatronics department, where they can focus on identifying accidents, and if an accident happens in the vehicles, how to actually detect them. And smart environments, everyone now tries to use smart bells inside home, automatic ACs and stuff like that. So that comes under smart environments. And surveillance video analytics. So everyone tries to has a surveillance camera nowadays, every bank, everything. But how do you analyze them? We are just recording data, but how do we analyze them? Do we need to analyze them? So that comes under this. So I would like to give some research highlights. Before I give my research highlights, I'd like to talk about how actually I came across these research topics. Zoom out. Can you zoom out? Zoom out. Is it possible?
You want to compress it?
Let me. I think this is. I think this is fine, right? Okay. I think let's stick to this. It's fine. So yeah, I wanted to talk about how actually my research went. So even before I started my bachelor's or before I started my master's, so I actually came across my guide in batch BTech, who actually talked about what is called as compression, what is called as video content analysis. So this is basically trying to understand the images that we record or images that we take. So just taking these images, people were taking lots of data, people were recording lots of data, but we actually need to analyze them. So then I actually identified if we can actually do something with this. And at that time in 2012, 2010, people did not work as much in machine learning. There was no such word at that time. So what was main thing at that time was mostly in signal processing, especially Fourier transforms. People are working in that area. Dictionary learning, this was very hot at that time in 2010. So using dictionary learning, I tried to find out if we can actually classify between different classes, or classify between the images that we take. So that helped me in getting much needed experience to work in masters. And even as I joined masters, there were these initiatives where IIT Hyderabad was taking, where they wanted to collaborate with the industries, even government there. So the main thing was in Hyderabad traffic, there were a lot of people who were not wearing an helmet. Like people, even I see everywhere, there were people not wearing an helmet. But in IIT Hyderabad, it was especially severe because the accidents were increasing. And most of the reasons for these accidents was they were people, especially everyday people, the reason was not wearing an helmet. Even small accidents, the people just falling down, it was leading to a death. It should not be the cause that way. So to change that, they came to IIT Hyderabad for help, and luckily I was in the CSE department at that time doing this research. And because of that, I was able to get, I will show you how it actually looks. So this is how it actually looks, where we were able to in 2015, I started this work. So we were actually able to give this software to the Hyderabad Traffic Police, where we try first identify the motorcyclists, and after identifying the motorcyclists, we were able to get the head region of the part, and after that, so this was at the time people did not have this solution. They knew how to do this, but they did not know how to do this fastly. That was the main thing, efficiently, because people were still using machine learning algorithms at that time, and the machine learning algorithms, they were very accurate, but I will talk about the machine learning and deep learning in the following slides, but they were accurate, but the main issue was they take a lot of time. And why is it that way? Why? So this is how the solution works, and this was the software which was then bought from Hyderabad Traffic Police from other states. Now this is around every corner nowadays, and sometimes even my friends say me, why did you have to work on this? Because we are getting challans every day. That's so yeah. That is one of the most research which I was personally very proud of, because it was actually something which helped society, and that is what I want you also, like everyone here, to focus on. See problems, or make your courses, make your teaching in such a way that it helps the society, where even the students are motivated to help something in the society, because without that, there is no value to what we are trying to teach. And the next thing was working in Oppo. So at that time, as IIT Hyderabad generally has a lot of IT companies, lot of industries working there. So IIT Hyderabad is the first point of contact whenever they have any problem. And because of that, they do a lot of projects. So one such project I was which was in Oppo mobiles at the time in 2020. There was no people detection in smartphones. Oppo was trying to solve that. How to identify just people, because they do not want to identify all the other stuff. When people take photos, they just want to identify the important stuff, and obviously people are the most important. So we were able to, I was personally leading this project to detect, and we were recently, even not recently, 2 years ago, sorry, but shown in National Geographic channel, where we were, this is my guide and my principal investigator who actually guided this project along with me, Shon Krishna Mohan and Shobhan Babu. So these are something which should be the aim of what we are trying to do. Anything which we do has to be helpful that way. So in my introduction, you heard smart environments. So it was introduced, I was working in smart environment. So what exactly is a smart environment? And it is not specific to, again, CSE department. this is something where every department or every domain is actually collaborating, they work together. So smart system basically, it tries to have something which understands its environment. It understands what's happening to its environment and analyzes it. So that is basically what a smart system is. And this can be grouped into again two different indoor and outdoor smart environments. Indoor smart environments basically are smart homes. So trying to put smart switches, everything through sound, making a sound to switch on a light. Again, everything comes under smart environments. Giving a notification through an email if someone who doesn't know comes in front of the door through a camera, smart environment. That's all indoor smart environment. Outdoor smart environment is basically trying to send a drone to do find out where people are. Sometimes in military scenarios, what happens, they want to find out if any person is there in a certain area. So that is basically outdoor smart environments. Drones, autonomous vehicles, all of these. When I mean autonomous vehicles, it is basically another word for self-driving vehicles. You must have heard the company Tesla.
Yes.
So this is basically similar to that. Yeah. So this is mostly how my work is divided. I initially started out on indoor smart environments because again, at that time when I started working, the computation was a very big issue. So I worked on something very simple, where old people were falling down, and to identify them, you actually have to detect them through cameras. Because what happened was, generally people have these sensors that they put on old people in these old age homes, or some bracelets, and when they fall down, it detects. But these bracelets are generally very expensive, so it is not a good solution if there are like 100 old people in an old age home. So to solve this, I proposed a solution where it can detect any person falling just putting a camera at the end of the room. So it didn't matter how many people were in the room, it still detected them and detected them falling down. So again, something which helps the society. And similar thing with outdoor environments, helmetless motorcyclists, again detecting accidents. So detecting an accident after it happens, generally it's a good solution, it's a good problem, but you generally have to identify when an accident is just about to happen. Because sometimes currently we have Wi-Fi network, and these cars are so smart right now that they can actually avoid an accident if they know if an accident is about to happen. If you know the dashboard, the steering wheel in front of your driving, it can actually pull out that cushion even before, just as the bumper touches another car. So using that, we were able to anticipate an accident even before it happens on highways. So I will show you how it looks later. And now after that, a main issue with detecting, as I said, when I said detecting, identifying these objects from a drone or an autonomous vehicle, the main issue was, the previous solution generally was identifying just one person or one object at a time. People were generally unable to identify multiple objects at a time when a drone was going through a land or somewhere. And this multi-object detection was actually, it's very hot right now, where people try to identify multiple objects in a camera or through a drone. And similarly, prediction. As I've shown here, you need to understand what you're doing, the past history, previous history, everything. So, how an accident happens, even before an accident happens, you just want to understand what happens, because sometimes you see people making rules in traffic. So you see a junction having a lot of crowd. So what do they do sometimes? They extend the road. But how do you make these decisions? Not everyone can be at all the places identifying what the issue is. In some places speed breakers might be more. In some places there might be some other issues. So understanding the behavior of how the vehicles move is also important. So that's why trajectory prediction is something which I gradually focused on after detection, because that was the next stage. So again, this is just an example showing the accuracy, but if you see here, no helmet, but as you see, basically what I'm trying to say is this detection of multiple signals, I would say, because that would be much more specific. This detection of multiple signals is very important, and detection of multiple signals simultaneously is very difficult, or you need to find efficient methods to find multiple signals at the same time. And this is an accident, how to detect an accident. So even before the accident happens, you can actually see in this video that you see a path generated here. I don't know if you can see it. Can you see this? The red. So red basically means that it is going, the car is not going normally. It is actually breaking some rules. So as soon as the red is detected, you can see this car was in an accident. But if it was able to detect, we were able to detect here itself, but the accident happened here. So this basically saying we are still finding, so there are a lot of stuff to find solutions. And the main example is this. The reason I'm showing this picture is identifying helmetless motorcyclists is actually a solved problem abroad in states with developed nations, I would say, because they follow the rules. I would say they follow the rules, and there is a lot of space between vehicles in other countries like USA or these other countries, Europe. It's actually easy to solve this problem because it's similar to finding a signal without noise, similar to identifying a signal without noise. It's easier to find it. But in Indian scenarios is where the issue comes in. There is a lot of noise. So because of this, all the previous algorithms are useless now, because they have made their, you have to remember the same thing. There are some state-of-the-art algorithms, but the main thing you have to focus on is what data they are working on. Because every time I see in not only this, in many courses, in many talks, what data they are working on is important, not the solutions. Because if they are solving a very tough problem on a very tough data, that is much more important than solving an easy problem on an easy data. Finding solutions to an easy data is very easy, everyone can do it. But finding solutions to difficult scenarios is important. And in this case, in cases like this, your previous, whatever the previous papers you see, sometimes you can actually improve upon them. So don't feel like, okay, this area is a solved issue. So let's just take speech recognition for like signal processing specific. Let's take speech recognition. Identifying, and does anyone know multiple speaker recognition? Has anyone heard about it? Identifying how many people there are in a voice call. So that is generally what, there were some algorithms to identify them earlier, but when multiple people came into the voice call, all the previous algorithms were gone. But that solution did not come 2 years later, even after voice calls came in. The reason was people gave up. People just gave up that, okay, this people have already found a solution, and they stopped searching through it. So you need to look at the data. You need to look at problems like this. Now everyone hears about these topics. Yes. Which one? So currently, yeah, signal. I think right now generative adversarial networks is something which people use. So you hear these words a lot in most of these talks. Artificial intelligence, machine learning, deep learning. What is the difference between them? What is so basically the overall topic is basically artificial intelligence. Yeah, that's Is it okay now?
Yes.
I think it's better.
Yes.
Were you not able to hear earlier or? Okay. I can repeat a few slides.
No problem.
Okay. So yeah, artificial intelligence is basically the overall success, the final rule, because and there are not many rules here. So as you go deeper, the rules keep increasing. So this is similar to the institute's autonomous property. What is an institute when it becomes autonomous? The same way artificial intelligence, it has a certain specific rules that machine learning and deep learning should follow. They cannot actually do anything without following these rules. So artificial intelligence is basically trying to make a certain system follow certain rules. That is basically artificial intelligence, for making it understand what happens. But when we come to machine learning, so we get a bit more specific now. The rules increase. So now we are trying to give these systems like mobile phones, computers, the ability to learn the rules on their own. So now you don't actually give the rules. The rules actually are being done by the system or being done by the algorithm. That is machine learning. Machine is learning. Now, then what is deep learning? When we come to deep learning, now it's actually trying to understand not just the rules, but it is trying to understand what actually the human form looks like. So you can say deep learning is most trying to mimic the brain. So it is even here machine is learning, but here machine is thinking. So it is even trying to understand what is needed to make the rules. Are you understanding how specific things are getting now? So deep learning is trying to mimic the brain, where everything you try to do is trying to make an algorithm work like a brain. So now you should have at least a better understanding when people talk about this topic, what they're trying to do. Yeah, so a simple example. So generally feature extraction, so basically in any algorithm, before you even start a problem, you find out what is needed, what the inputs are, and then what features are needed. So features, when I say features here, so I'm just giving an example. So we are trying to find out if a person is a male or a female. So when we are trying to person a male is a female, or if a person is old or not old, we find out what features are needed, like hair length, or sometimes their age, stuff like that. And if you see machine learning, even the feature extraction, what features are needed to identify if a person is old or if a person has a heart attack, when we go to a doctor prescription, even that is separate from actual classification. So even before we start the learning phase, the feature extraction is separate in machine learning. But in deep learning, it is all combined. Even what features are needed, we are letting the algorithm learn. And how are we letting this learn? I'll discuss in the coming slides. But that is basically an important point where the feature extraction is also happening simultaneously as the learning is happening.
So you can say that machine learning is supervised learning and deep learning is more focused on unsupervised.
Yeah, and but so even in machine learning there is unsupervised learning. But now what is the difference between unsupervised learning and deep learning? So in unsupervised learning, the parameters, the initial input is defined, right? So, but in deep learning it isn't. Even this can change. That's the difference. So, because even in machine learning there is unsupervised learning, there are unsupervised algorithms, but yeah. So as I said, now when we come to signal processing specific, generally what we try to do is, let's say there is a matrix and we are trying to, how machine learning or even general algorithms solve the problem is, they try to flatten it. Because if it's in a signal, so now it's in a signal, when it is in a sequential information, you can actually use general signal processing algorithms to solve the problems. So that's what people were trying to do in 2010, 2005, very earlier. So they didn't actually try to come up with any algorithms. What they were trying to do is, they were trying to convert everything into a signal. But slowly they realized this was not effective. Why? Because of different channels. So in signal processing, everything is sequential. Everything is, you have a sequence. Everything is ordered. Even the voice, there is a time factor to it. You can actually go through the time over everything. But this is not the case when images and videos are involved, which is what mostly deep learning try to focus on, and even text. So even earlier when there are any text information, so again everything has a sequence. Now when images get involved, especially color images, there are now 3 different matrices like RGB, red, green, blue. So now you are actually trying to solve a problem for 3 different kinds of information at the same time. So this does not work now. Converting everything into a sequence and trying to apply basic signal processing. So now it's a completely different. Now how do you solve this? Okay, now we found out the problem. Okay, now there are multiple channels. Now what? Now what do people do? And has anyone heard about ChatGPT? So can anyone tell what it is? What do people use it for? For your assignments? Coding assignments? Yeah, so now if you think about it, that is again a similar issue like this, right? Because it is trying to find an answer which it doesn't know. So it is different from Google search, because Google search already has all the information inside it. But in ChatGPT, what is happening is, when you try to give a question, it has similar data of what Google has, but it is making connections as you ask the question. It does not have the rules inside it already. Are you understanding why it is different from Google search now? Because Google search is just giving you what it has. It's just giving you 10 lists, 10 top lists, 10 top links. But ChatGPT is actually finding the connections based on your questions at the time. Now again, that is trying to find 3 different channels at the same time. So that's why you see deep learning coming everywhere now. Because whenever there are multiple data involved, multiple data trying to solve at the same time, you have